Let me just start this video by saying don't try anything that I'm about to show you at home. As I've stated many times before, I'm not suggesting anyone go in and modify their own meter. These meters are only used for my own evaluation. I never use these on any kind of high energy source. The most energy they're ever exposed to is off of my small surge generators. If you're working with a high energy source or you need a meter that meets the EMC standards, just buy a meter that meets it and has been certified to meet it. And with that said, I hope you enjoy the video. Hello again. In this video we're going to continue to look at the UT61E and what it would take to make it a more robust meter. In the first video we damaged these two transistors, and that was with a 4000 volt transient, so we've definitely made some gains on the meter's robustness. This is looking at the circuit board out of the UT61E that 5KY had sent me. I had hit this meter with the same transient and I damaged the same two transistors. I'm not too surprised by that, but let's have a look at the schematic. So if we follow the signal, it comes in on the input jack, goes through this PTC. We now have a MOV installed. We follow the trace up, it goes through our selector switch, and we can either be in hertz, capacitance, diode check, or the millivolt range. And all four of those will go into this Q1, Q8 clamp and back to the return ground. Again, that's just the common point of the meter. From there it works its way through 4 more selectors. So on the back side of these, if we follow them around, we'll see there's a series resistor on that one, and on this one here, and on this one here. So what they're trying to do is limit the current when this thing clamps going back into the IC chip. The problem is there's nothing that limits the current after this MOV clamps. So what ends up happening is this MOV basically doesn't do anything. So basically what ends up happening is all the energy that's fed in here goes through the rotary switch and then through these two transistors. And of course these aren't going to be made to handle that kind of energy. Unfortunately, if we look at this other run, again we can see it coming through the PTC, and again we have a MOV installed now. We follow it up, goes through the selector switch, and again this is in the capacitance mode, would be the worst case. Goes straight down into another clamp. So this clamp is made out of 3904s. Q1 and Q8 are not the same thing. They're marked a D882. Nearest I can tell, that's a 30 volt, 3 amp, 100 megahertz, 500 milliwatt part, and that would be a 2SD882 is the part number. I think what I'm going to do is replace these with a TVS, and then I'm going to put some kind of a series resistor in here. So again, when I hit this thing with a transient, it's going to go through this PTC, through this MOV, and back to ground. This will limit the amount of energy that's fed up and then through this leg into ground. So why am I not worried about this leg? Well, I haven't damaged these set of transistors yet. And when I ran 5KY's meter, of course I ran this at a much higher transient. That's what's actually damaged this ground trace up in here. So I ran this meter through all the same modes with a much bigger transient, and for some reason these lived. So I think what we're going to do, like I say, is we'll mod the original 61E. We're going to replace these two transistors with some TVS's, and then we're going to put a series resistor in line with those. So for me, making the mods to this meter, it's really out of my own interest. It's not that I'm ever going to use this meter. Again, I've replaced the two transistors below here with two TVS's, and you can see this black blob up here. This is doped over two resistors that I've added, and hopefully again that's going to limit the current that feeds down to the TVS's. So other than that, the meter is now ready to go. There's one problem to adding the TVS's, is that their capacitance is a little higher than what the transistors were. So the resting capacitance on this now, I think, is like a nanofarad. So I have the meter back together, and I've got it selected right now for capacitance mode, and you can see it's reading roughly a nanofarad. Again, the leads are just opened up. So normally the way, again, that you're going to use this anyway is you're going to rel this out and you're going to select your capacitor. So again, this is 150 picofarad. So, you know, a lot of the meters that I test can't even read down this far. But yeah, it seems to be fine. I think I'm going to leave all the calibrations and everything just the way they are, still from the factory. And again, this added capacitance is due to changing out those 2 transistors for some TVSs. Right now the scope is set for 2 kV per division, so roughly 3 kV. We'll just start here because we did make a change, and then we'll work our way up. Okay, so this will be again 5 transients each at 3 kV. Let's just see if we've damaged anything yet. Doesn't appear so. If we did damage that section, this thing would read 0 ohms. Or something low. Again, let's just have a look. Looks fine. Again, let's have a quick check. Looks good. Yep, everything seems fine. Okay, that's it. We'll go ahead and check it. Okay, the meter's just fine. I've just set up the transient generator. Again, this 2 kV per division, or roughly 4,000 volts. Again, that's what damaged the meter the last time. So it should be a little more robust now with that couple of changes that we made. Let's just find out. Let's just have a look. Yep, no problem so far. Looks fine. Yep. So far it's looking good. Of course, we won't know until we actually run the tests on it, but okay, we'll go ahead and functional test it. Let's have a quick look though. Yeah, pretty good chance it's going to be just fine. So there's some good news and bad news. The good news is it actually passed the 4 kV test. The bad news is I got a little cocky and I cranked that generator all the way up to the maximum setting. And the series limiting resistors that I had placed in there to save those 2 transistors, those got damaged. So I went ahead and changed the value of those resistors. See, it's reading roughly a nanofarad, and this is our 100 mega ohm resistor. So it looks fine. So what I've done is I've reset the generator back up for max. I cut out all that testing. It was kind of pointless. Hopefully here this time we're going to pass this test. So here we go. 5 transients again. Plus and minus at almost 6,000 volts. Okay, let's just have a quick look. Alright, so I've run through a complete test with this meter. Everything looks fine. So that is roughly 6,000 volts again coming out of this generator for that test. Very few meters actually survived those tests. These are the meters that failed at the 5,000 volt level, and that was the Hold Peak HP760H, the UNI-T UT61E and the Keysight 1231A. So there you go. This thing is out surviving what a Keysight meter actually held up to. Of course, it's taken quite a few hours to get it to that point, so hardly worth the cost there if you figure your time. So you can see it's just reading 150 puff. Very constant, no problems at all. And again, this is with your 10 mega ohm resistor. See, it's quite stable. So the meter itself looks pretty good. I am impressed that it can read 100 meg. That just that's pretty amazing right there. You don't see too many meters that can do that. Here's with a short. I mean, really, it works pretty good. Here's with a 0.5 ohm. Here's a 50 ohm. Here's 100. 1K. You know, everything looks real good. It's with a bigger capacitor, so this is a 10 microfarad. There's continuity. And diode check mode. Here's our short. And here's a single diode. And 2 diodes attached. Of course, it still can't do 3. Holy crap. What? I'll figure that. So something that I've done has actually scaled this thing up just enough to squeak and get that third diode in there. So there's 2 diodes. And again, there's 3 diodes. What the heck is going on there? So when I first got the meter, I had taken a bunch of measurements with it just so I could kind of track the changes as I was going through. And our open circuit voltage is still the same as what it was, so I'm not sure how come it's able to do this measurement all of a sudden. But there you go, that's 3 diodes right there. And again, there's 2 and there's 1. Go figure. Of course, I guess we have a new test that we need to run now. Let's put this thing into our DC volts mode. This is mentioned by Scott. He runs a YouTube channel called Gadget Review Videos. He came up with this whole Flyswatter measurement thing. So let's just see what happens here. And you can see we have juice. So I'm just going to tie this thing direct. Let's make sure she's working first. Oh yeah. Let's see if this will take out our 61E. Nope, just goes over range. The meter will trip over range at just over 1,000 volts. I think it's 1,010 is what the data sheets had said. And that's what it's strapped for. So I'm not too surprised. Let's try to reverse it. Yep, no problem at all. So here's our 5 volt reference again. And here it is reversed. And no problem. So there you have it. The 61E survives the Flyswatter test as well. I think that's going to be it for this video. I've already spent way more time than what this meter is even worth. I just wanted to show people that even though you may hear things on the internet, people will give advice about things, in this case about putting MOVs or GDTs into this meter, saying that that's somehow going to improve something. Hopefully I've shown you here that it takes a lot more than just changing the MOVs in this meter to really help this thing out. Now, I'm not suggesting that I've made this meter safer in any way. Again, this channel has absolutely nothing to do with safety. You know, I'll have people tell me that, oh, I'm putting all this energy out, and I'm telling you, even with this guy here, about 600 joules, this thing here, less than 20 when I'm running it. So I'd like to welcome again you new members. Hopefully you're enjoying these videos. Till the next meter.